Alright, in the last class, we covered some basic concepts related to machine learning. We learned that a AI agent learns to think through machine learning. We also explored the two phases of machine learning, the training phase and the prediction phase, also known as the testing phase. In machine learning, each piece of data we use is called a sample. Depending on these two phases, samples are divided to training samples and testing samples. What do we call the model that a computer acquires after training and learning? That's right, we can call it a learning model. Now, what are some of the commonly used machine learning models in the process of machine learning? Today, we will talk about the classification of the models in machine learning. The commonly used model in machine learning includes classification models, regression models, and clustering models. Each type of model is built using different learning algorithms. First, let's look at the classification models. As the name suggests, classification models are used to categorize things based on the certain features. For example, when predicting whether a user will click on an online advertisement, the prediction outcome are binary, clicks or doesn't click. In this scenario, there are two classification results. Another example is the spam filtering. In this scenario, an email is either the spam or not spam, just two possibilities. We classify the prediction like spam filtering and the user ad clicks, which has two classification outcomes as the binary classification. However, when predicting weather conditions, the two outcomes aren't enough. We need more prediction results, like sunny, rainy, snowing days, and so on. When there are multiple prediction categories, we call it multi-class classification problem. Look this. This is a result of emotional recognition by an intelligent robot. It's a multi-class classification problem. Apart from classification models, another commonly used model including regression models and clustering models. Regression models investigate the quantitative relationship between independent variables, which are the features of data we introduced earlier, and the dependent variables, which are the prediction results we mentioned before. This relationship can be linear or nonlinear. Regression relationship can be linear or nonlinear. Let's hypothesize that if independent variables or data feature is equals x, and the dependent variable or the prediction result is equals y. If there's a formula like y equals a times x plus b, we can infer that the model satisfying this formula is a linear regression model. Linear models can be classified into simple linear models and multiple linear models. For example, the production model for urban housing process is a multiple linear model. Let's elaborate on this model. It's built on the relationship between the housing prices and the factors that influence them. When building the model, by selecting the features from amount of housing sales data, we can identify the main factors affecting the average housing prices, such as the per capita income x1, the per capita savings x2, housing production costs x3, and the average customer spending on the housing x4. Establish a linear relationship among them, resulting a multiple linear regression model. Let's look at this formula. Y equals a1 times x1 plus a2 times x1 x2 plus a3 times x3 plus a4 times x4, and finally we don't forget to add a constant epsilon 1. If we can analyze these influence factors a1, a2, a3 for the constant epsilon 1 through the computer algorithm, we can obtain a prediction model for the housing process. This allows us to predict future trends in housing process, and we can provide targeted and reasonable suggestion. The third type of the common model is the clustering model. First, look at this definition of clustering models. Clustering models divide data into groups with the maximum the similarity and with the highest similarity within each group. You may know that airlines has accumulated amount of member data and flight records. Based on this data, airplanes can classify their members into different tiers, such as key retain customers, key development customers, key recovery customers, and January customers, and low-value customers. Airlines can adopt different marketing and service structures for the customers of different tiers. In daily life, the most common application of clustering model is the recommendation system. For example, when we buy some products on the Amazon website, the next time we log in, we will find that the system recommends the many similar products to us. How does Amazon make these recommendations? Actually, they recommend this based on the item similarity. Today, we will learn about the most common models in machine learning, mainly classification models, regression models, and clustering models. So how does machine learning generate these models through learning? Okay, we'll explain that in the next class.